Imagine if every time you needed a new door jig, you could just input some parameters into your computer and press print. That is exactly how a parametric model works. Watch as I adjust the height of this flush pull jig. Now we'll do the width. We can do the back set. We can even do the thickness of the jig. Stick around and I'll show you how to make your very own parametric door jig model. All right, so this is a quick video on how to do parametric modeling for jig making. In this case specifically a flush pull jig for doors, which is something as carpenters we end up doing quite a bit, so I think it's a good choice. So what a parametric model means is that we're not going to freehand draw it. We're going to put in the parameters, and then we're going to use the parameters to drive the model. And that way, if we change parameters down the road, what will happen is it'll change the shape of the model. This way, you're not having to draw or model every jig that you're trying to do. You can just change the parameters. So if you're doing flush pulls today that are, 200 millimeters by 30 millimeters, and then tomorrow they're 165 millimeters by 35 millimeters, you just need to change those parameters, and then you can print that model or print that jig and bring it to work and use it. This way you're not having to remodel every time. So it's not going to be an exhaustive look at Fusion 360. It's going to be more of a recipe style, step by step. And if you follow each step, you're going to end up with a parametric model at the end. All you need to do is change the parameters in order to change the size of the model and then print it. All right, let's get started. We're going to start by clicking on the little disk up here and saving our project. So I'm going to call this flush pull jig TUT for tutorial, and we're going to save that. Now with every Fusion project, we want to start by creating a new component. So new component from parent, and the parent is going to be our main file. Let's call our component here flush pull jig. That's pretty good. FPJ will do. Okay. So as I stated before, this is a parametric model. Now what a parametric model is we're going to use parameters to drive the model. We don't want to freehand draw it and have to edit those dimensions later if we want to change those dimensions at all. We want to just change the parameters, and that will change the model. So it starts with putting in some parameters. Now this is a little bit dry, but if you bear with me, when we get through this, we'll get to doing some modeling and our parametric model will work. So to start here, we're going to start with tolerance, TOL. Now 3D printers have fairly tight tolerances for woodworking. They have fairly tight tolerances. They're out generally about 0.2 to 0.4 millimeters, and they're generally a little bit bigger than what you're after. So what we do is put in the tolerance here. I'm going to go 0.2. It's a good starting point. As you get to know your printer better and get to measuring some of your pieces using calipers afterwards, you can get a better idea of what the tolerances are. It's also dependent on your, so it's dependent on your printer, it's dependent on your settings and the filament you're using. Those will change your tolerances. And the reason why we put it in as a parameter is if we added all of the tolerances to all of our measurements throughout the model, and for some reason we just figured out that our tolerance was a little different, we'd have to go to each one of those measurements and adjust the tolerance. By doing it this way, we only have one place that we need to make that change. Okay? So there's tolerances. Now, the next size is going to be or the next parameter is going to be our size of the mortise we want to make. So we're going to start with width. And the expression for width is going to be, now we're using those Halliday-Bailey pulls on this one, and I've got some measurements that we're going to start with. So the width is 30 millimeters, but we're also going to add our tolerance here, plus TOL. And hit enter. Press OK. And now we're going to do our height. And our height for this one is 156 millimeters. 156 millimeters and plus TOL. Again. The next measurement is going to be our backset. Backset. And that for this one is going to be 55 millimeters plus TOL. The next parameter is going to be plate. Now I call this plate, you can call it whatever you want. I call it plate. This is what our router is going to sit on when we're routing it out. And what I do is I take the mortise size and I add some meat around the outside, so I have something for the router to ride on. For this, it's not critical that we're accurate to any degree, so we don't need to add for tolerance. And I'm going to put in 1 inch. You'll notice that everything else was in millimeters, and I put in 1 inch here. So you can also add imperial values if your settings are on millimeters. I like to keep my settings on millimeters, but for things that I need to visualize in a carpentry way, because I do my carpentry using imperial, I also can put in imperial measurements. So you see 1 inch there gives us 25.4 millimeters. If you wanted, say, 1 1/4, you'd go 1 space quarter inch, and that'll give us 31.75. But we're just going to do 1 inch for now, and that is our plate. So the next parameter is going to be thick. This is going to be the thickness of our jig. It doesn't have to have any degree of accuracy either, so we are going to go 1/2 inch, and enter. Okay, and that's a good start. We can work with these parameters and get our model started. Also, a quick note, if you are using a bushing or a larger bearing, you need to add that in right now, and you do it a lot. You do it exactly the same way you're doing tolerances. You add it to the dimensions where it matters as an offset. The next thing we want to do is create a sketch. So we'll go up here into this corner here and we click sketch. We're going to use this bottom plane here and we're going to start a sketch. Now, to start, what we want is a rectangle. And we're going to go to rectangle. Don't use this one. We're going to go to rectangle. We're going to go to center rectangle. Click on the center and stretch it out here. Don't click anything. Now this is where we start to use our parameters. Now, if you were just going to do this from scratch and not use parameters, you would just enter the width and the height here. But because we're doing this parametrically, what we're going to do is type in width there, hit the tab button, and I'll put us down here, and that'll go height. Now you have to hit enter twice because you're accepting height, and then you're accepting your measurements. So there, you hit enter twice. So we've got a height of 156 and a width of 30 millimeters. And when you see the FX in front, that means that it's using a formula. And you can click on it, and its width is your parameter that you're using. Okay, the next thing we want to do is create a reference point for our jig. And the perfect reference point is going to be our backset. So let's put the backset in. We're also going to do another thing here. We're going to put 2 center lines, one to the top and one to the bottom. And it's going to give us a visual representation of the build volume that we're that we have to work with. So our 3D printer build volume is 256 by 256 by 256. These flush poles can tend to be a little bit tall sometimes, and you want to be careful that you're not exceeding that build volume with your jig. Now, sometimes you can exceed it quite a bit, and what you need to do then is get your jig going diagonally, and sometimes you might need to trim some of the edges off afterwards of your model. You do it afterwards of your model so that it'll fit within your build volume. We're not going to worry about that right now. You don't need to get that creative because this one's going to fit quite nicely onto our build plate. So what we're going to do is we're going to put in 2 lines. So L, and we're going to go to the top, and we're going to go 128 because that's half of 256. And then we're going to do L again for line, start from the center, come down, and we're going to go 128 again. All right. Now what we want to do is click those 2 lines, and then we're going to click O. And that's for offset. And you see that our red line is going to the right side. Visually, you can do it either way, but I like to work off to the left, or it's going to the left side, I want to go to the right side. So I'm going to use a negative value here. And that negative value is going to be backset. You're going to hit enter to accept backset as the line, and enter again to accept the measurement. So now what we have is we have the mortise pocket that we're going to router in. We have our reference edge. Now let's put in our plate, and that's what our router is going to ride on. So we're going to do a rectangle again. No, we're not going to do a rectangle. What we're going to do is we're going to offset this rectangle. So we're going to go O, and then we're going to click on the rectangle and see how it wants to go to the inside. So we need to do a negative value again. So we're going to go negative, and this was plate. That's the dimension we had there. Enter to accept that, and enter again to enter our measurement. The next thing we need to do is offset another line from our 2 center ones here, and this will make a little more sense in a minute. So click them, and we're going to go offset. They want to go to the left, we want them to go to the right, so we're going to use a negative, and we are going to go backset. Actually, let's put this in brackets. Let's go backset plus thick, and enter. Now we're going to do a 3-point rectangle. So go to rectangle, and this is a 3-point rectangle. This is going to make the main body of the jig. So click on the top left there, the bottom left there, extend it out, and zoom right in on this one. We want the X and the square on there. Okay? And now we want to go up here to constraints, and coincident is the one we want, and we want to click there and hit escape. Now I'm just going to test to make sure that that constraint worked properly. What I'm going to do is go to modify, change parameters, and I'm going to change thickness. If it changes thickness and I see them move together, then I know that I've got my constraint done properly. So I'm going to change it to a 3/4 inch thick and hit enter. And it didn't constrain. Now it should be constrained. Let's try that again. Change parameters, and we'll go to 1/2 inch. Now they're constrained together. That's really important that we get that right. Okay. So now we have the sketch that we're going to extrude our jig out of. We have our reference back set to center. We have our pocket that we're going to take out. We've got a plate, something for our router to ride on. And then we have our main body of the jig. So we can finish the sketch. Click finish. And now if anybody here has used SketchUp before, you probably know how to do this stuff. So we're going to extrude. We can press E, or you can press this up here. So E, and we want all of the parts that we want to extrude up. All of those parts there. Notice our arrow is pointing up. And so instead of putting a numeric value in here, we want to put in thick, and that will make it thick. And you'll notice that our sketch disappeared. We still need that sketch. It does it every time after you do your first extrusion. So we'll click the sketch again. It's in here under sketches. And if we go around to the back, we want to click on this. And now this is our reference edge. What we probably want this reference edge to come out is the thickness of the door. So we could either type in 1 3/8 or 1 3/4, or we can create a new parameter for that. So let's create a new parameter for that. And we're going to call it door thick. And we're going to go 1 space 3/4. You never know, you might be doing a 2 1/4 door. 1 3/8. So there you go. Now we have a new parameter in there. And we are going to extrude that. So you see here our arrow is pointing in the wrong direction for us. So we need to use a negative value. Door thick. And that will pull it out the correct thickness. Now we can turn our sketch off. We don't need to see that anymore. And we basically have a jig. Let's put a few finishing touches on it. What I would like to have is a reference for center so that I know how to line it up on my doors. So what I'm going to do is I'm going to create another sketch. We're going to select the face here, zoom in a little bit, and L for line, and pull it out this way, doesn't matter how far. Escape. Now we want to offset that line, so click on it, offset, and we'll go 3 millimeters. And then let's offset it again the other way, offset, we'll go -3 millimeters. Now we want to offset this line here, and let's go, once it's going in the wrong direction, we'll go use a negative value of 6 millimeters. Now what we're doing is putting a little notch in here. So we'll go L, and then L again, and escape. And we will finish the sketch. Now, let's select, let's extrude. We want that, and we'll go flip it around to the back, and it'll push right through. There. Now we have a center reference line. Now, there are many ways you can connect your jig to the door. You can use, some people will put masking tape and double-sided tape, or masking tape and CA glue. I like to put a couple screw holes in just in case, and you can put them in the end of the door. If it's paint grade door, they can always be filled. So we're going to put a sketch on this edge here, and we're going to put two screw holes. There are ways to do screw holes in Fusion 360. They don't work great for 3D printing. I prefer to make my own. I know how they work with, the number 8 screws that we usually have on site, so we're going to do it that way. So the first thing I want to do is I want to offset this line here. We're going to offset inwards, so we need to use a negative value again, and we're going to go door thick, and then divide that by 2. So that'll be in the center of our door. And then we're going to go to the top here, and we're going to O for offset again. We're going to go minus 3/4 inch. And do the same at the bottom. And that is O for offset minus 3/4 inch. Okay, so that's where our screw holes are going to go. So let's make those. C for circle. And then we'll go 5 millimeters. And then circle again. Oops, let's go to there. Circle again. And this one we're going to go 8.5 millimeters. I just know these values work because I use them all the time. Circle. We want 5. And then we want circle. And we want 8.5. Now what we want to do is we want to extrude the small circles first. So let's go extrude. And we'll flip it around to the back, and you'll see that those holes went right through. There, and of course we have to turn our sketch back on. This time we're gonna countersink these a little bit. So we're gonna go, we'll hit extrude first. And I like to countersink them by 1.5 millimeters. And see our arrow is going the wrong direction. So we need to go negative 1.5 for a countersink. Now we can turn that sketch off. Now what we want to do is put a little chamfer on these. So we're going to click on that one. And we're going to click on this one. We're going to go modify. No, not that. Hit escape. We need to click those again. That. Oh, I'm all over the shop right now. Okay. We got both those selected. Yes. We're going to go modify, chamfer. Now, the amount that we want to chamfer this is going to be, if I remember correctly, 1.75. And we'll have a look there and see, yeah, that chamfered it right to the edge. That's at a 45-degree chamfer. That works pretty good for number 8 screws and keeps it nice and centered and solid. Now you might be looking at this and you might be tempted to put in, your other mortises into this edge here for like your end pull or something. Now, 3D printing can't print in midair, so you have to be careful with overhangs. We can create bridges, but bridges tend to sag a little bit. So generally with 3D printing, you're going to want a different jig for each application, because when I print this, I'm going to print it flat on its face like this. I'm going to print it flat on its face like that, and it'll build all the layers up this way. If I had another mortise in here, as it's printing layer by layer by layer, it's going to get to the top of that mortise and it'll have to print in midair. And so the only way it knows how to do that is to create a bridge from there to there. And if you can imagine it, it's pulling the filament across there. You're going to have a little sag in there and you're not going to have very good accuracy. So, but all of the things that you've learned in making this jig apply the same way. You just need to put your reference at a different point, and then you can do your end pull as well. All right. I figured I should just quickly show you how to export your STL file while we're here. There are lots of tutorials online about this stuff, but while we're doing this, I might as well show you how. What you're going to do is go up to your file here and go to 3D print. And you need this to be on export. And you need to select the body. This is the body. And then you're going to press OK. and then it'll bring you into your file manager, and then you save. So give it a better name than body one, so you know what it is when you go looking for it. Anyway, so there's your jig tutorial. I hope it helped, and good luck.